Okay, folks, today's lesson, I find it super intriguing and exciting. I hope you can find it that way too, because yesterday was pretty straightforward. Find the angle, find the quadrants, inverse, solve, right? Today is just slightly different. We're going to solve more difficult trigonometric equations. What is different about problem 1? What about the fraction? It's in front of theta. All the other problems we've had, there hasn't been anything in front of theta. This causes a little bit more of a challenge. Not a big deal, but let's work through it. I subtract 2. Four sine of 2/3 theta is equal to -2. Sine of 2/3 theta is equal to -1/2. At this point, some people are tempted to do something that's incorrect. Anybody know what people sometimes do that is definitely not the right choice? Very good. They multiply by 3/2. In order to multiply by the 3/2, I first have to get rid of sine. The way we get rid of sine is we go through sine inverse process. So I set up my quadrants. Where is sine? Negative. 3 and 4. By now, because you've been so at work, you know where sine is equal to 1/2. What is sine inverse of 1/2? Very good, 30 degrees. You've seen that come up a few times, right? That the sine of 30 is a half, right? Okay, so there it is. So therefore, sine is gone. What remains? 2/3 theta. I have two angles. What are the two angles? 210 degrees and 330 degrees. Theta is then equal to, I multiply by 3, I divide by 2. 210 divided by 2 is 105 times 3 is 315 degrees. And 330 divided by 2 is 165 times 3 is 495 degrees. Those are my two answers. Sorry, divide by 2. It doesn't matter if you multiply by 3 and divide by 2 or divide by 2 and multiply by 3. It'll carry out the same way. Yes. So what we are going to do for these directions, okay, good point as you brought it up. This answer comes out to be 315. This answer comes out to be 495. I don't want you guys to have to go to the process of trying to work through deciding. You know, right now you might be saying, oh, well, it's really easy to just cross the 495 off. You're right. But suppose we ended up with this. Suppose we had x over 10 was equal to 40 and 210. Well, you would, I'm sorry, suppose you had 10x was equal to that. You divide by 10, you got x is 4 and 21. Well, you might have a few more then, right? Like, I mean, if they ended up as small as 4 and 21, you might be able to add more than just 40 and 210. Like, for example, if you came up with 600, take 600 divided by 10, you get 60, right? So I'm not going to make you do that. When the directions say solve for theta between 360 and 360, I want you to make sure that your initial setup results between 0 and 360, okay? So we could stay true to the directions. We simply just don't have time to devote it to that. And it's really not necessary for us. The application doesn't come up. We look at problem number 3. What's different about number 3? Everybody focuses on the square root. I'm focusing on something else. You got cosine and sine. I wish that there was a relationship that existed between sine and cosine. Sine divided by cosine is tangent. So could I come up with a tangent here? How? Look at that. So the problem looked confusing, and all we do is we divide by cosine, get negative root of 3 is equal to the tangent of x. Now that is easy to deal with. Where is tangent negative? Two and 4. Inverse tangent of the root of 3? 60. Very good. X is 120 and 300. Good job. Notice how the next one has two different options as well, right? We got cosecant and sine. Wish I knew the relationship between cosecant and sine. They're reciprocals? Good. What happens if you multiply two things together that are reciprocals? Yeah, so what if I try multiplying by sine of x over 2 and by sine of x over 2? So on the left side, they're reciprocal, so I'll end up with 1. And on the right side, I get 2 times sine squared of x over 2. Well, I think that equation looks a lot better than the original one. Wouldn't you agree? So let's solve that. How would you solve? What would you do? I do divide by 2. 1/2 is equal to sine squared of x divided by 2. I do square root both sides. And when I square root, I need to list both the positive and negative. Does anybody know what the square root of 1/2 simplifies to? I'm going to write this out so nobody gets lost with it. I take square root of top, I get 1. The bottom, I have the root of 2. Multiply top and bottom by the root of 2 over 2, root of 2, and I get root of 2 over 2. So that sounds like something that we're familiar with, doesn't it? So you plus or minus the root of 2 over 2 is equal to sine of x over 2. Lots of 2's in this problem. Thank you for your input. Vetoed. All right. So I'm not going to deal with the x over 2. I first need to get rid of. In which quadrants is sine positive and negative? All of them. You obviously know where sine is equal to the root of 2 over 2. 45 degrees. And so therefore, I have x over 2 is equal to 45 degrees, 135 degrees. What else? 225 degrees and 315 degrees. So I want those initial inverse results to be between 0 and 360. Now what do we do to finally solve for x? I get 90 degrees, 270 degrees, 450 degrees, and 630 degrees. What do you think? 2 more. 2 more. What's different about number 5? They're on the same side. I'm looking for something else as well. I have subtraction, but something else. They have a different variable because you have a 2x and an x. This is the first time we encounter a problem where you have a 2x and an x. So there are different kind of angles I'm working with, right? This is a single angle. This is a double angle. On top of that, I've got both sine and cosine. I wish that there was a formula I had that I could go from a double angle down to a single angle. Oh, it's the double angle formula. Sine of 2x is the same as Did anybody have a moment there where you're like, yeah, I would never think to do that on my own? That's normal, folks. The first time I saw the problem, I didn't think to do that either. So I'm trying to expose you to enough examples to where you're like, oh yeah, these are some of my resources. Now that I have that, what do you think I can do at this point? This is what you should be able to think about. What do you think I do now? Yeah, you're just going to cross out the cosines altogether because cosine minus cosine is 0. And you're going to factor out the cosine. And when you factor out the cosine, you're left with 2 sine of x minus 1. So I have the cosine of x is equal to 0. And then what's the next one going to be? Yeah, sine of x is equal to 1/2. Let's try to do this one without even really writing anything down. Sine of x equal to 1/2. X would be 30. Very good. And if it's 30 in the first quadrant, what will it be in the second quadrant? 150. So we got x is 30 degrees and 150 degrees. Thank you for entertaining me. Cosine equal to 0. Where is cosine x or y value? X. Where is the x value equal to 0? Think about your 90 and 270. Good. Nice work. Last example, number 6. We'll skip the other one. What do you think? This one, number 6. What do you want to do with 6? Divided by cosine sounds like a good idea. You would end up with 1, and then you get secant, and then you get tangent. So you get 1 plus secant is tangent. That doesn't really help either, does it? Yeah, it sounded like a good idea. Subtract the 1. Okay. Subtract over the cosine. Yeah, Jaden's got the idea. We need a squared. In order to be able to relate sine and cosine together, it sure would be nice if it was squared. So I'm going to square both sides. This is not a great idea. It's a good idea. The reason is when you square things, you add answers to make sure we know which ones work and which ones don't. But as long as we remember that, then it becomes a great idea. All right, so square the left. What do you get? The left side. Cosine squared of x plus 2 cosine of x plus 1 is equal to sine squared of x. So good, now I've got some squares, and the reason why I wanted the squares is because I'm going to make use of them. You see, I've got cosine and sine, I need to have just one or the other. Is there something I can plug in for something so that it's all either cosine or all sine? Power reducing formulas is an excellent option, except power reducing formulas give us double angles, and then that kind of defeats the purpose. Fortunately, we know sine squared is equal to 1 minus cosine squared. That's the reason why Jaden said to square both sides. She knew she would come up with a sine squared, and then from that, she could plug in a 1 minus cosine squared. She just didn't say it because she didn't want to kind of be a know-it-all. So I have cosine squared of x plus 2 cosine of x plus 1 is equal to 1 minus cosine squared of x. I like that better. What should I do? Subtract the 1s? Great. 1s are gone. Then what? Yeah, add the cosine squared over the other side, says Henshi. He's absolutely right. We get 2 cosine squared of x plus 2 cosine of x is equal to 0, which is Spanish for 0. Yep. Yeah, I took a full semester when I was in high school. Oh, man. You need to go get some brain food. Come on back. Okay, let's finish it off. I got 2 cosine squared plus 2 cosine. What do? I factor out 2 cosine of x. Very good. When I factor out 2 cosine of x, what am I left with? Great. So I've got 2 expressions now. I've got 2 cosine of x is equal to 0. And I have cosine of x plus 1 is equal to 0. So where is cosine of x equal to -1? Cosine is the x value. And so you can see over 180 degrees, the x value is -1. So x equal to 180 degrees. Alex is on the ball today. Good job. And then we divide by 2, and you're wondering where is cosine of x equal to 0? So where is the x value equal to 0? 90 and 270. Okay, so Henrik has already gotten a step ahead of us. He is checking these answers. He remembers we got to check them because when we squared it, we maybe added a solution that does not work out. Let's plug it in and see what we get. We'll try the 90. Cosine of 90 is? Very good, 0. And the sine of 90 is 1. So is that statement true? Yep. So we got 90. Let's try 270. Cosine 270? Sine of 270. Is that true? No. So we got to get rid of the 270. 180. Cosine of 180? -1. Sine of 180. Is that true? Yes. So the solution is x is equal to 90 degrees and 180 degrees. There you have it. You're now able to complete the rest of your assignment. The problems aren't easy. If you need to come in for help, please come and see me. I'm going to hand out your homework cover sheet and your study guide. I would like you to also take out your homework. I'll come and just check to see where you're at. Go.